Hey class, so today we're gonna go over zeros of quadratic functions. Now, don't be like, oh, that sounds crazy, like what are we gonna do? Like, hold up. First, let's start with something simple, okay? So, what kind of sports do you guys all like? Basketball. Let's go. Football. Soccer. Okay, anything else? B?
Gymnastics.
Okay, that'll work too, okay?
Track.
Swimming. Yes, okay. So, what was that?
Like shot put.
True. Okay, that actually works really well with what I'm going to go into. So, the reason why I asked you about sports is that we all like sports, and if you didn't know, there's mathematics in that too. So, let's go to a quick video, and it won't work. That's fine. Okay. That's fine. I have.
Nice recovery.
There you go.
Have you solved any quadratic equations lately? Chances are you have. In fact, a lot of Americans spend several hours each week not only solving quadratic equations, but watching other people solve them as well. If you haven't guessed by now, I'm talking about watching sports on television. You didn't pull out your pencil and paper and work through the quadratic formula to solve the equation, but your brain still makes an attempt to do it just by watching. When the ball is thrown, kicked, or hit, the trajectory of balls is parabolic and is described algebraically by a quadratic equation. This is somewhat of a simplification. It does not take into account things like wind resistance, but it is a good basic model of the field. The quadratic equation usually has two distinct solutions, the points where it crosses the x-axis. In a real-world sports scenario, these would correspond to the following points: the point where the ball started from, and the point where it would hit the ground, or go through the net, or be caught, depending on the sport. So who writes the quadratic equation in sports? Let's start with the football example. Here the author is the quarterback. When he drops back to throw a long pass, he determines the point where he believes his receiver will be, and he throws the ball in a parabolic arc aimed at that point. In other words, he has written a quadratic equation with a particular solution in mind. When the receiver sees the ball, his eyes begin to track it long enough to pick up the trajectory so that he can run to the solution and arrive just in time to catch the ball.
Okay, that's enough for that video. So you guys basically get the gist where we're gonna be working with quadratic equations, and they had the picture that they showed up right before. I can zoom back to it real quick, I believe. So boom, right here, look, example. You have a football player quarterback throwing a football to a receiver, and as you can tell, the trajectory of the football creates what? A problem, yeah. And in this case, it's one that goes upside down. So, and what we're actually going to be solving for when we're talking about zeros of quadratic equations is the points where either it first leaves or where it hits the ground or hits your target. That's what we're going to be talking about.
So there's multiple zeros?
Yes, so actually we're gonna get into the definition of a zero, but basically a zero equation is when a graph or a function crosses the x-axis. And we call it zero because the value for x in that case is, actually the value for y is 0. Because it's on top of the x-axis. Okay. So today's objective is, B, can you actually read that for me?
Students will be able to create equivalent
Sorry.
representations of quadratic functions by finishing a worksheet showing the different ways to factor and calculate the zeros of a function.
Awesome, thank you. So we're gonna go over some vocabulary. So the zeros of a function are values of x that will cause your y to be 0. So kind of like how I explained, it's going to be when the function crosses that x-axis. You guys want me to write this down? And then we'll be using factoring. We went over factoring a little bit before, but it's basically just breaking down your function into simpler terms. And then dealing with factoring is the common factor, and that's going to be the simplest terms that multiple terms have in common. So, for instance, let's say you have x squared plus x. Oh, you can't see that really. That's fine. Well, you have x squared and x, and then if you break down x squared, that's just going to turn into x times x plus x, and you can see that this term and the next term have an x in common. So that's what the common factor would be. Oh, sweet, thank you. I'll just write that. Oh, sweet. Okay, so let's start off simple. In terms of linear equations, when you find the 0 of a linear equation using a graph, you just look for the x-intercept if any exists, and that's where your x value is going to be at. So, with this example, based on what we just learned, your 0 for this equation is going to be right here. So, as you can see, the y value for this point is 0, and its 2 is going to be your 0 actually. It's going to be your value of x that causes the y to be 0. Super easy, right? Right? Not too complicated. Okay, your turn. So, just by yourself, just look at this graph and just see if you can figure out where the 0 of the equation is, and if you can come up with a specific point. Cool. You can work by yourselves, you can even work with your partner, just discuss it real quick. Somebody have the attendance sheet? Okay, Justin, can you tell me, what do you have for this?
I have 1, 0.
1, 0?
Yeah, where x is 1 but y is 0.
Okay. Yeah, and I would agree with you on that, right? Because when you go out 1, the graph crosses it right there. Yeah. Or the function crosses the x-axis right there. I'm sure you could find an equation for it and solve for it, so you can find a specific to make sure you're actually right. But yeah, it looks good to me. And then using an equation, there you go. So finding the 0 of this linear function. So based on our definition, right, what is a 0? Gage, can you tell me what a 0 is? Just 0 function?
The values of x that causes y to go to 0.
Okay, exactly. So what do you think would be the first? What would you think would be the first step in solving this for a 0?
Leaving x by itself.
Not quite.
Plugging in a 0 where the x is.
Do you need to factor it? Maybe not.
No, those are both good ideas. I'm gonna go. He's actually the closest. So actually, you don't plug in 0 for the x. You plug in 0 for the y. Cause if it's on the x-axis, it's got no y, up or down, you know what I mean?
Yeah.
So, in this case, you would plug in the 0 for the y. Okay, never mind. Oh. There you go, plug in 0 for the y. So you're gonna, so for this one right here, you're gonna plug in 0 for the y, then you're gonna get the, who said get the x by itself? Okay, so that was a good idea, but it just comes after you plug in the 0 for the y. It makes it easier
Okay.
to move stuff around. And after you move stuff around, you get that x equals 2. So 0 for the graph would be, when it's 2, 0 would be the point. And then on your own, on your own for first minute, try to find the 0, y equals 9x minus 5. And then when you're done, just discuss with your partner, and then we'll have people share.